Let us move on to the next problem, which is problem number 2 in the lecture. And this one is telling that two satellites S1 and S2 revolve round a planet in coplanar circular orbits in the same sense. Their periods of revolution are 1 hour and 8 hours respectively. The radius of the orbit of S1 is 10 to the power 4 kilometers. When S2 is closest to S1, find the speed of S2 relative to S1. The application of Kepler's third law of planetary motion. Let us first write down the data they have provided. We have been given that the period of revolution of satellite S1, let me call it T1, this is 1 hour. For a change, I am just keeping the units as given, that is known as SI units. It will be helpful in doing this problem. And the time period of revolution of satellite S2, I call it T2, that is given to be 8 hours. Also, radius of the circular orbit of S1, let the symbol be R1 for that, and this R1 is given to be 10 to the power 4 kilometers. We have to find out the speed of S2 relative to S1 when they come closest, that is V2 minus V1 modulus value of that. This is the question. Okay, first of all, let's recall the Kepler's third law. It says that the square of period of revolution of a planet round the sun is proportional to the cube of the length of semi-major axis of the elliptical orbit. We can modify the statement under the situation. Since they have mentioned a circular orbit, we might say, by extending this law for satellite motion also, the square of period of revolution of a satellite round a planet is proportional to the cube of the radius of its circular orbit. That is, T square is proportional to R cube. It follows therefore that T square is equal to a constant proportionality K into R cube. For satellite S1, we might write down the time period T1 square is equal to K into R1 cube. And similarly, for satellite S2, time period T2 square is equal to the same constant K into R2 cube. Therefore, taking ratios of these two equations, we might get that T1 square by T2 square is equal to K into R1 cube by K into R2 cube. The K's cancel out, and you are getting from here R1 cube by R2 cube is equal to T1 square by T2 square. Little bit of rearrangement. We are finding R2 cube is equal to T2 by T1 whole square into R1 cube. We have been given the values of T1, T2 as well as R1. Therefore, we are getting R2 cube is equal to T2 is given to be 8 hours, T1 is given to be 1 hour, and the ratio is squared. The value of R1 is given to be 10 to the power 4 kilometers, and this quantity is cubed. You can see 8 by 1, well, hours cancel out. 8 square is 64, that is 4 cube. I might write the right hand side to be 4 into 10 to the power 4 kilometer. This is cubed. And it follows therefore that R2 is coming out to be 4 into 10 to the power 4 kilometer. That is the first important step result. We have been given the radius of the orbit of satellite 1. We have now found out the radius of the circular orbit of satellite 2. Once we are here, we can find out the orbital speed of satellite S1. This is V1 given by the perimeter of its orbit, that is 2 into pi into R1 divided by the time period T1. Putting the values, this is 2 pi R1 is known to be 10 to the power 4 kilometers and T1 is given to be 1 hour. So V1 is coming out to be 2 pi into 10 to the power 4 kilometer per hour. Similarly, the orbital speed of satellite S2, V2 is given by perimeter of its orbit 2 pi R2 divided by its time period T2. Putting the values once again, 2 pi R2 has been just now found out, 4 into 10 to the power 4 kilometers divided by T2, that is given to be 8 hours. This is, you can check 8 in numerator as well as in denominator cancelling out, leaving us with pi into 10 to the power 4 kilometer per hour. Once we find the orbital speeds of these two satellites, when they come closest, moving in the same sense, the relative speed of satellite S2 with respect to S1 is given by the absolute value of the difference, V2 minus V1. This is modulus of pi into 10 to the power 4 kilometer per hour minus 2 pi into 10 to the power 4 kilometer per hour. You can see the result is coming out to be a negative quantity, but since we are taking the absolute value for that to get relative speed, we should report the positive value for that. That is pi. Pi means 3.14 into 10 to the power 4 kilometer per hour. And this is the answer of this question. You conclude that relative speed of satellite S2 with respect to S1 when the come closest is 3.14 into 10 to the power 4 kilometer per hour. This question little unusual because even without converting the units into SI, we have done it in a convenient manner. That you must take note of.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.